In this lecture, I'll talk about external validity and sampling design. Now, if you recall, last week we talked about internal validity, which is concerned with accurately identifying cause and effect within a study. So internal validity is managed within the study by controlling elements, assigning participants to conditions, whereas external validity is concerned with how far we can generalize results beyond a study sample. So how can we generalize outside of what happened in the study? And this is largely dependent on how the study sample was selected or how we bring people into the study. So internal validity is really about what the researchers are doing within the bounds of a study. But external validity has more to do with how people come in and how data can be generalized out. So it has more to do with an exchange between the study and the real world. So there are several terms related to samples that you'll want to be paying attention to. So sampling procedures are the techniques that determine who or what and how many to study in order to produce valid results. So who are we studying typically? Or what units are we studying? Because sometimes we're studying individuals and sometimes we might be studying couples or families. How many individuals or couples or families do we need in order to be able to produce meaningful results and meaningful data? So here are some of the components of that. An element is the unit you're going to collect data from. So most of the time in studies, we're collecting data from individuals. We may be surveying individuals. We may have individuals going through treatments and we're collecting data from them that way. But sometimes, particularly in the marriage and family therapy field, the unit we're collecting data from is relational. We might be collecting data from a couple. You might collect data from a family or a mother and child dyad. So what is the unit, the whole unit that we're really studying in a study? So the population is all theoretically possible elements. So if we're studying couples, the population would be all theoretically possible couples that would qualify for our study. So we need to define the population that we're studying, but we might not actually know the whole population, meaning I can say the population I'm studying are married, different gender couples of all races between the ages of 25 and 50. So now I've defined my population, but I don't actually know the whole population. There's no list anywhere of all couples that fit those inclusion criteria. The sample is our collection of elements that we take from that population. So now my sample is all of the couples that I'm able to take from that total population and bring them into my study. And the frame is ideally the same as the population. So this is who we're going to draw from, but not always, because I don't have access to all different gender couples between the ages of 25 and 50. But I could, say, recruit couples from various private practices or agencies. And then my sampling frame would be all couples who are in couples therapy, between the ages of 25 and 50, different gender, at agencies in Fairfield County. So you can see how the sampling frame is similar to the population, but it's not quite as big. So another example would be, let's say you want to study MFTs in Connecticut. So what is the element? The element is one person defined as an MFT. So what is the population? All theoretically possible elements. If I'm studying MFTs in Connecticut, then the population would be any MFT in the state of Connecticut. So I can define that. Can I know it? So can I get a list of all MFTs in Connecticut? No, probably not, because I haven't defined them as licensed or unlicensed. I could theoretically get a list of all licensed MFTs in Connecticut, but that would exclude folks who don't have their license yet, or perhaps are not currently practicing or currently licensed, but may still identify as MFTs. So we have to be really clear about who we are including or not including in our sample. So if I can't get a list of all people who identify as MFTs in the state, I could still create a sampling frame that could help me draw from that population. So I could do a sampling frame of all clinical members of CT-AMFT. So that is something where I could get a total list, and then I could randomly select from that total list. However, I would have to account for the people who I'm not able to include in that sample, the people who are not going to be on the list. So there are two major kinds of sampling designs. There's probability sampling and there's non-probability sampling. Probability sampling is also known as random sampling, and it's often regarded as a better kind of sampling. So sampling with higher external validity because it reduces sampling error. So it reduces the chance that there's meaningful differences between who you sampled and the population you were trying to generalize to. And that's because statistically speaking, if we randomly sample from an entire population, that sample we get should be representative of that larger population. And one of the ways that we can examine this is by comparing our sample statistics to our population parameters. So in other words, who is in our sample versus who is in the total population, and how close do these match? So these two pie charts I have here are an example from my dissertation. So I randomly sampled from Ohio State undergraduate students. So through Ohio State, the registrar's office, they will provide a random sample of all students, and then I can sample from that. So here we have the gender of my student sample compared to the reported sex of the entire student population at Ohio State. So you can see that my sample included a few transgender students, and Ohio State does not collect, at the time, did not collect data on transgender students or gender identity. They only collected data on sex. You can also see in my student sample, I had 61% female identified students, whereas in the total population, it was 49% women. So what this tells you is that the sample that I pulled from the entire population is not exactly representative, at least by gender, of that larger population. So that tells you that there is some sampling error in my sampling design here. There's a couple ways that we can randomly sample. So simple random sampling is what it is. It's simply randomly selecting from the entire population. So if, and every element in a sampling frame has an equal chance of being selected. Now, in order to do this, you have to have a complete list of the entire population. So if I wanted to do a study on MFT students in the program, if I did simple random sampling, I would take the entire list of all matriculated students and randomly select a sample from that list. Now, stratified random sampling, the population is divided into meaningful groups or meaningful levels, and then you randomly sample from each of those groups. So let's say I wanted, equal representation from preclinical and clinical students. So then I could create a complete list of preclinical students, a complete list of clinical students, and then I would randomly sample from both of those lists until I had a sample that was half and half. Assuming that the entire population isn't half and half, this would be a way of equally selecting from both groups, but still doing so randomly. And now if you have overrepresented or underrepresented groups, then you can disproportionately randomly sample. So if I had a list of all female students and a list of all male students, I might want to over select from the list of all male students to have more balanced representation between the two genders in my sample. Now, cluster sampling is when you randomly select from clusters of a population and then you sample individuals or elements within those clusters. So let's say if there's 4 MFT master's programs in the state of Connecticut. So let's say from those, I randomly sampled from those 4 programs and I pulled Fairfield and Southern. And then what I can do is randomly sample from the programs of Fairfield and Southern. And theoretically, I can still generalize my findings to all MFT programs in the state of Connecticut. So these stratified random sampling and cluster sampling, you would do those instead of simple random sampling when randomly sampling might be just too big of an ordeal, or when there are particular groups that you want to make sure are represented in your study. More commonly in the social sciences, we're going to see non-probability sampling because we have very few lists of entire populations. So it's very difficult to do random sampling. It's also very costly to do random sampling. Another point where non-probability sampling is a very appropriate method of sampling is when we're doing experiments. Because remember, there's internal validity and external validity. And internal validity is controlled within the experiment, and external validity has to do with who comes into the study and how we generalize out of it. So in experiments, internal validity is much more important because we're controlling for a lot of the differences between people or between the people in our sample in the study. So we can use non-probability sampling for experiments because we're controlling for the internal validity more so. But if you're doing a survey where internal validity really is not a factor, then your sampling methods become more important. So non-probability sampling does reduce the external validity of a study because your samples are not necessarily representative of the population. It's very common in psychology research to use samples of college students, right? You can get them, you can require them to sign up for studies if they're psych students. You can give extra credits for students who do studies. And then a lot of that research is then generalized to the entire adult population. And we know that college students do not represent the entire adult population. The other thing we can't control for with non-probability sampling are selection effects. So who is actually going to volunteer to participate in a study and who is not going to volunteer? And when we're not randomly sampling, when we don't know who didn't participate, it's very hard for us to know the differences between the people who volunteered and the people who didn't. So there's a couple different methods of non-probability sampling. The most common, the one you're going to see most often, is convenience sampling. And that is where we just select the convenient and available elements, people usually, who fit our inclusion criteria. So this is, just asking for volunteers in a research study, or sometimes volunteers or participants are referred to a research study. And so you're basically taking anybody who's willing to participate who meets your inclusion criteria. Purposive and quota sampling are also non-probability methods, but have to do when you also want to control the different kinds of groups that are in your sample. So often it has to do with demographics or people who have had particular experiences. So you may purposively sample from certain groups, or you may continue to sample until numbers are met in different groups. And snowball sampling is more common in qualitative research where you may be trying to find folks that are in kind of hard to reach or hidden populations. And so you ask your participants to refer other people to your study. But again, the most common type of sampling we're going to see in social science research is convenience sampling. Regardless of whether you use probability or non-probability sampling, not everyone who you ask to be in your study will agree to do that. So researchers often want to calculate a response rate by dividing the number of actual participants by those in the entire sample. So how many people that you invited to participate actually did. Now, of course, this is quite difficult to determine with non-probability sampling because you don't have a list of your entire population or your entire sampling frame. And oftentimes, you don't know all of the people who actually received the invitation to participate in your study. Think about the number of times you maybe have seen a survey on Facebook or you've gotten a survey in your email. if a survey is pushed out through Facebook, we have no way of knowing how many people have actually seen that invitation to participate and then chosen to participate. So with non-probability sampling, we often cannot calculate a response rate. When you can, you should compare who actually responded and who didn't respond to see if there's any differences there. So for example, in my dissertation, I had a portion of the population of undergraduate students, and I could see who had actually responded to my invitation and who did not. And so I could look for differences in who responded and who didn't. And as you can guess by the two pie charts I showed you, females were more likely to respond to the survey than males. So in general, a response rate below 50% when you know it and you can calculate it is not great. Above 70% is very good. And more often you can actually calculate a response rate if you're doing, say, mailed surveys or like random digit dialing. And so you know how many people you are sending invitations to, and you can count how many you're getting back. So a big question that people ask is, how many is enough in your sample? What is a big enough sample? And the answer is, it depends. It depends on the different facets of your study. It depends on how big the whole population is that you're trying to generalize to. You know, sometimes you want your sample to be relative to how you're generalizing, how much error you're willing to accept in your results, how much risk of error, how much variance there is in the population. So how much do people in that population differ in terms of what you're interested in measuring? So researchers can conduct what's called a power analysis before they start a study. A power analysis is a series of statistical equations that will basically tell you how large your sample needs to be in order to detect significant differences between participants. So if researchers conduct power analyses, and they'll often do this in larger quantitative studies, they should report the results, and their sample hopefully will be about the size of the power analysis told them it should be. Now, sometimes we think the bigger the sample, the better, and that's not necessarily true. Because when your sample sizes are huge, like over 1,000, it's very easy to detect differences between people. So tiny differences that might not be meaningful in real life show up as significant when you have thousands of people in a sample. And then similarly, when a sample is very small, it can be difficult to detect differences, or you could detect differences that aren't actually meaningful in real life. So unfortunately, the answer is, how big is big enough depends on the study. And I know we have talked about with experiments, you don't necessarily need a large sample because you're not as concerned with external validity as you are with internal validity. So you're controlling for a lot of the error in research by manipulating what's happening inside the experiment. So you don't necessarily need a larger sample or to do random sampling to increase your external validity. And we'll continue to talk about sample sizes and what is appropriate for sampling as we talk about different methods of research. So we've talked about experiments, we will talk about surveys, we will also talk about qualitative research, qualitative interviews. And so we'll talk about sampling with each of those.